Cool. Hello, everyone. My name is Jordan. I'm here to talk about slaying the assembly conflict dragon with assembly load context. It's a very lengthy title. This is sort of a bit of a deeper dive into sort of PowerShell assemblies, .NET assemblies and PowerShell, and how you can structure your modules to try and stop stepping on other people's toes. So before I begin, just have a quick thanks to our sponsors. Without them, we wouldn't have this wonderful conference, seeing each other, listening to all these fantastic talks. So I highly encourage you to go to their booths, talk to them, see what they're all about. Quick intro. Once again, my name is Jordan. I'm a software engineer and I work for Red Hat. I work on the Ansible project, which is sort of a configuration management tool, specializing on the Windows integration. So I have a bit of a task with PowerShell modules and other stuff like that. I enjoy working with Python, PowerShell, and as sort of a bit of a hobby on my side projects with C#. It's a fairly fun project, language. Recently, I'm a proud father, sleep notwithstanding, of one baby. He's taken up a lot of my free time with the spare projects. So it's been excellent, but yeah, it's a different challenge from what I'm used to. So the problem. Basically, when you write modules, you can either write them as pure PowerShell scripts and have no dependencies on there. But if you're getting into more complex scenarios, you might want to reach out to .NET assemblies that does all that work for you and abstracts all the difficult details. So like with the Spectre console stuff, you have a specific assembly for that. One of the problems is that PowerShell loads modules in one process. A process since .NET 7 can only load one version of an assembly, and modules that use the same assembly but with different versions, we now have a conflict. So putting that into practice, a real-world example that we have here is the old mcell.ps module from Microsoft and DBA tools. Both these modules here have a dependency on Microsoft Identity Client, and they have a dependency at different versions. So in this case here, I can import mcell.ps by itself. When I run this one here, the location of this one here is in our mcell module, and the version is at 4.37. Hopefully that's not too small for everyone. Silence is golden. We can do the same thing. So if I'm running with DBA tools, it also has that dependency. When we run this one here, we import DBA tools. It's in the DBA tools location, and they have a version of 4.53. So we have a conflict here. So what happens when you try and load both of them at the same time? In this case here, I'm just going to quickly comment out this code here to show you what's going to happen. So if we run import DBA tools, the wrong part. If we import DBA tools before mcell.ps, we're importing the newer version before the old one, but we're still going to have some issues. We have mcell.ps is prompting us, saying that there's a conflict. Do we want to continue? In this case here, we don't want to continue because we want an error message. So we have an error. We can supply these optional arguments to mcell. These cases here, they're actual specific options for this module. So it's not something generic that you can do on all modules. This is implemented specifically in this module, where it's essentially saying, hey, be lenient with the versions that you want. If it's already present, just use that one there and don't put the actual prompt. So in this case here, we run this one again. We'll import DBA tools, then mcell.ps with the options, and then we can see that PowerShell itself has loaded the 4.53 version, which is the one from DBA tools. So we have two modules here somewhat cooperating together, but they're doing some tricky magic to try and get this one working, and it just doesn't really work out too well in the long run, which I'll show you a bit later. If we do the opposite now, so we're going to import mcell.ps before DBA tools. So in this case here, this will import the older version of the assembly before the new one expected by DBA tools. And we can see here that it is going to error, saying it cannot import Microsoft Data SQL clients. That's the main one that DBA tools is importing, which then has a dependency on our Microsoft Identity Client version here. When that one has run, because PowerShell hasn't exited itself, we can see that the old version is still at 4.37. So we'll have mcell.ps present, but we cannot import DBA tools in that same process. So that's the main issue that we're sort of trying to overcome here. Unfortunately, there are things that you can do, which I'll get into to try and alleviate that for Windows PowerShell, so version 5.1. But you cannot fully solve this problem with that one there. You're always going to have some edge cases which may not be solvable. The only thing that you can really do is run it in a separate process. So things like start job or just spawning PowerShell separately for the different module. So let's get into workarounds and other ways that we can try and fix this. So the first option that we have here is using an assembly load resolver. So in this case here, we have our PowerShell process, we have our module PSD1 and PSM1, which contains our scripts and functions, and it has a dependency, a .NET assembly DLL. If we look at our example of this one here, so we have an assembly resolver, we can see that the PSD1 is very basic. We're just exporting two functions, so get new value, get old value, and the root module itself is a PSM1. This PSM is essentially, it has one function in here. What it does is it lists all the current assemblies that have been loaded into the process. So it checks to make sure things like the Microsoft Identity Client is already present. It will create a delegate, so like a script block or a Lambda if you're in the previous talk, which will run whenever .NET will try to load this assembly. So it's able to preempt whether it is already loaded and pass in the old one, if possible, or use the current one located in our actual module itself. So it has a whole bunch of things there to try and extract the path that's been requested, get the name from that one and the versions, checks whether the assembly is currently present or not in the process. If so, returns that. Otherwise, it loads that from the path itself. From there, we just use add type itself to load that assembly. We also do some very basic cleanup once the function ends to remove our delegate from that actual event. So we don't want to have this script block run when our module is now out of scope, because you can actually cause the process to crash because there's no session state associated with it anymore. So that's just sort of some basic cleanup that we have on here. Finally, from there, we then have our DLLs that we're importing. So we have a shared dependency. So this is a DLL that I've written, which I'll load in some examples, and a parent dependency that's reliant on the shared one. It will import that using our function that we've written, and then we just define two functions here. So the first one gets an old value and gets a new value. If we look at our parent dep, which is just some C# code, we can see that it has get old value and get new value defined on there. And in that case there, it's just pulling that from a shared dependency. One is in an old version. This one here has some squiggly lines because it's only defined in a new one. That's just to show you what happens when you have some conflicts that are happening here. But it's basically a shim that will then call that shared dependency to sort of illustrate what is actually happening here. So we close that one up here and let's look at this one in action. So in this case here, we can load our module just fine without any issues. So if we run this one here, we're importing our assembly resolver module. We can call get old value and get new value, which will return our strings. And then our parent dependency is located in the module. Our shared dependency is also located in the module, and everything's all good. We have it at the new version that's imported there. If we're lucky, someone may have already imported that same version. So in this case here, someone has imported the shared dependency before we've imported our module. Whether that's another module or something else, it really depends. We then import our assembly resolver and things just work just fine. So we're lucky that we're able to meet those dependencies and things just work. But when things don't work, so we're going to be importing an older version. In this case here, parent dep1 has version, I think, 1.0.0. And then we import our module. We'll find that if we're trying to call get old value or get new value, it's actually going to fail with a particular error. It's going to say the located assemblies manifest definition does not match the assembly reference. There's maybe 3 or 4 different scenarios that can happen here. It really depends on whether you're calling the DLL directly. It's a dependency on another one, versions that are imported. So it's hard to really pin down that error message, but it can be very confusing for people to try and figure out what's happening. So if we run this one here, we can see that the tests pass because we're expecting these errors here. We're also able to see that the parent dependency has still been loaded by our module, but the shared dependency is in that sort of older version, so the version 1.0.0.1. So we have a conflict there, and we can see that our assembly resolver isn't actually able to help us in this particular situation. So it's not really fit for the task. It helps in some, but not all. Essentially, some pros and cons. The pros, you don't really need any UX changes for your modules, so you don't need to change parameter types or anything to retrofit this particular option to a module. So it might be nice to make it a bit simpler or a bit easier for people to use, but it won't fix the problem entirely. You can use this method with Windows PowerShell. It's needed less there because it doesn't have that strict requirement of unique assemblies, but there may be some scenarios where it might be useful. So this can be used to alleviate some of those scenarios. Some cons. There's so many edge cases. Trying to create this demo here that will actually run just drove me crazy. When it's actually being run, like in VS Code or in the terminal, things can change, the error messages that are on there. There's just so many things I had to try and handle. Even the demo yesterday that I tried, I had to change a few things to get it working. So there's so many different things that can go wrong, and honestly, I probably haven't even done it 100% correctly. It expands your test matrix. So now you need to contend with, is this version assembly installed? Is this one installed? And what happens when they interact with each other? I've got dependencies on dependencies. There's so many different permutations that you need to try and deal with, try and get it working. And even then, it may not work all the time. So it's a band-aid, not an actual fix. So out of 10, I rate this a 1. Essentially, it's a fail. So how do we actually solve this one here? We use a concept called an assembly load context, which is a new thing introduced with .NET, I believe it's .NET 5, so PowerShell 7.2, that's able to load your dependencies in an entirely separate concept called an ALC, or an assembly load context. So the first example that I'll show you here is how you can use an ALC in a pure script-based PowerShell module. So in this case, we have our PowerShell process, we have our PSD1, a PSM, which has all our script files, and that will create and manage our ALC, which stores all our dependencies that are actually inside there. So let's have a look at that one there. So if we go to our, script ALC, we can see that the PSM one here, it has a few sort of setup work that we have on there. So first we're checking, are we running in PowerShell 7 or .NET Core is what it used to be called. If we are, we're loading Tomlin, which is a TOML-based library. We're creating a new assembly load context with a particular name. In this case, we're just calling it the same thing as our module. We're then creating our assembly object. So this is a rich object that we can use inside PowerShell from that actual ALC. So the ALC load assembly path loads that assembly from the path into the ALC and not where PowerShell is located. If we're using PowerShell 5.1, we just do the normal thing where we just call add type and hope for the best. There's really not too much you can do in that particular scenario. So we have our assembly object, either in both PowerShell 7 or PowerShell 5.1. We then have to do some tricky things to try and make it a bit more usable in our scripts, because now that it's located in an ALC, we cannot reference that type directly using the square brackets. That's one of the particular issues with the script-based approach. To try and solve that, what I do is that I create a hash table. So that's just bound to our module script scope. I then loop through all the types that I care about. So in this case, it's just the full type name. I then find or extract that type from our assembly object, and I store that inside the hash table. So from there, I now have a hash table with all these items conveniently available for later use. So if we see at our actual function, so our get TOML property display kind, all this is doing is it's taking in a string value and it's going to cast that to an enum value that's located inside the Tomlin assembly. So when we're using it, normally in PowerShell, you'll use these square brackets here. So we have the Tomlin model, TOML property display kind, and then our value, because it's just how that works, or we can cast it using the as syntax. Because we cannot reference those types directly, instead we have to use that hash table we defined before and just use a string value to look up that type object. Another approach as well is to use get the type object from there and just use that sort of casting syntax there. Different ways of going from it, but instead of using the square brackets by themselves, we just have to look up that value either through a variable or in this case here, a hash table. So if we look at this particular example, we can see that in our before blocks, this is going to be running before each of the tests. We're going to be importing an old Tomlin version. So this is going to be version, I think, 0.18, whereas our module has 0.19, which includes a new property just to illustrate how we've got these both versions loaded in the same process. So in this case here, PowerShell itself, if we're using the normal type syntax, still only sees the old version, so 0.18, and the location is in that older path. The older version, so if we try and do this manually to get the no inline value from that enum, is going to be empty because it doesn't exist in that version. The ALC module, so we're going to use our function that we've defined on there to convert our no inline string to the enum value, and that works there because it actually has access to the newer TOML assembly inside our ALC. We can do some trickery to try and extract the metadata from that type. So in this case here, we're going to get that value and get the assembly object from that value. We can see that the location is located in our root. It's just a Tomlin DLL. And then the version is going to be at 0.19. So not 18, we now have 19. And that one there passes. The type that we get from there, sorry, let's go to the next one. We can check the type by name. So this is one of the hiccups when you're dealing with a dependency stored inside an ALC. You cannot do the is syntax check like that we have here, because that's only going to be able to resolve the types known to PowerShell. You have to use strings when you're comparing types like this one here. And that's one of the hiccups that you have to sort of deal with. And the easiest way is just don't expose these types directly to PowerShell or use some sort of wrapper type. So if we run this one here, just to show that this one here is actually true. If you look at the ALC that's located for the type known to PowerShell, we can see that it's located in the default one, which is essentially where PowerShell is stored or is running in, versus if we run that from a value returned from our ALC script module, will be inside our script ALC. So this sort of works. You can do that with your script modules, but essentially the biggest pro is that you don't need any C# code. So if you don't want to learn C# or you don't want to mess with compiling modules and anything like that, this does work. It isolates your dependencies and it's something you can do. The cons, you do need to rethink your inputs and outputs, basically because PowerShell cannot reference those types, so you can't define a type on that parameter and hope it does its casting conversions. It is also complex to write. So you saw that very basic example on there, and that's very contrived. As soon as you start getting into more complex scenarios, it's not going to be something that's easily maintainable. I hope there's something that we can try and improve in PowerShell in the future to try and make it a bit better, but right now it's just not really there. So I score that a 3 out of 10. It works, but it's not something I would really recommend your modules to do for your modules, just because it's weird to write and it sort of goes against some of the PowerShell language ethos that we have there. So the next option that we have here is the ALC Resolver. So these are just names that I've called them. They could be called anything else, but it's how I distinguish between them. In this case here, we have our default ALC. So that's that main block here. We have our PSD1, and then we have our module DLL, which contains all our commandlets and other things that we want to have facing to PowerShell itself. That DLL, when it's imported, sets up an ALC, so our custom ALC here. It imports this private module, which is another one that we have defined, which then also depends on dependencies. Some of the simpler examples probably skips this private DLL method, but there's a reason why I recommend you have it on there. Because if you don't have it, you run the risk of inadvertently exposing some of your dependencies that could have been loaded before your ALC is set up. So this is just sort of a safety switch to make sure that it's done properly. So if we look at that in action and see what that actually looks like, we go to our ALC Resolver. With the PSD1 is fairly simple. The main difference is really that you're importing 2 different DLLs depending on your PowerShell version. And then once again, we're also exporting our getTOML property display kind value. If you look at the code itself, we have 2 different projects. We have ALC Resolver and ALC Resolver Private. The Resolver one is the main one that we're exposing from PowerShell itself. So that's this DLL that we're loading here. If we look at the code, it is quite simple. So we're defining a commandlet on here. but we can't reference our Tomlin DLL directly inside this assembly because we run that risk of exposing the Tomlin dependencies. So what we have to do is we have to use sort of an intermediate or a shim, another util that's located inside our private one. So if we look at ALC Resolver Private, we can see that toml util is defined here. It has that pass property display kind value. So if we go back to this property here, that's that pass property display kind. The ALC Resolver, the CS project, is quite simple. You're just importing your system management automation or your PowerShell standard library based on the version. And then you're just making it dependent on your private one, so it's able to resolve that at compile time. The main magic that sets up your ALC is this on import and remove code. So it uses the iModule assembly initializer and iModule assembly cleanup, which is special interfaces from PowerShell. When it encounters these particular implementations inside an assembly as a module, it will call the onImport method and then the onRemove method when the module is unloaded. So this is a nice way of being able to hook into actions when your module's imported. In this case here, we're creating an assembly at ALC event resolver. So we're resolving this one here, and we're just removing that resolver when the module is unloaded. All this one does is it checks whether the DLL exists. So if we go to our bin folder, net 8.0, so it will get a request, hey, does ALC resolver.private exist? If it does in this folder, load that inside the ALC. Does tomlin.dll exist? Yes, load it inside the ALC. The ALC itself is very, very simple. We're just implementing the base class there. We're specifying a name for this one here, and we just have that same logic again where does this DLL exist in this directory? If so, load it in our ALC. One of the key things to point out is that we have a public static class here with a public method inside our private assembly. You won't be able to access this inside PowerShell itself without using some reflection work to try and access it. So it's not something you can access directly. It's going to be located completely inside our ALC. So let's look at our tests here. So we can see that, once again, we're going to import our old version of Tomlin, so the 0.18 version. We're going to import our ALC Resolver library before each test. PowerShell can only see the 0.18 version, so the old one. The old one doesn't have the no inline enum value on there, so that's going to be null or empty. Our get toml property display kind commandlet inside our assembly is going to work because it has access to the types inside the ALC. The type returned from that commandlet is not going to be checkable through the square braces. You're going to have to, sorry, wrong one. The assembly is going to be the one inside our module at 0.19, so it has access to the new types there. And we can't check the type by name using those square brackets. We have to use that string one. So the same issues that we had with our script-based one was everything's located directly inside that ALC and not accessible by PowerShell itself. I won't go through these again because it's essentially the same thing. So default ALC for the one loaded in PowerShell versus ALC Resolver for the one that's returned from our commandlet. And then I was talking before about our static method and a class and method. We can't actually resolve that directly in PowerShell itself because it's all located inside the ALC and it has no idea what this type is and where it's located. We can use reflection to access that. So in this case here, we're just calling this here to make sure that the module has been loaded. We then enumerate the assemblies in our app domain. So this includes everything, including all our ALCs. We find the assembly that's called ALC Resolver.private. And then from there, we get our static class, and then we call our static method from there. So it's a very roundabout way to extract that static class from ALC assembly. It's possible, but it's not very pretty, and it's not something I recommend you tell people to actually do. So that's the ALC Resolver method. The pros, there's no need for a PSM1. So if you're dealing with just binary modules only, you have a DLL, a PSD1, and that's essentially it. The structure is very similar to how simple C# modules work. So once again, you don't need the PSM1. It's all sort of C# code. And it's sort of simpler in how it works. So you don't have to have too much boilerplate to get this all set up and working, unlike the next example that I'll go into. The cons, once again, as it's an ALC-based approach, you do need to rethink your inputs and outputs because you cannot access your dependency types through like functions or in PowerShell itself. This is not strictly necessary, but you really should wrap your dependencies in another assembly. So that's that private one. If you don't do that, you essentially run the risk of inadvertently exposing those types and then coming back into that problem before, where you have a conflict and a clash potentially with other loaded ones. So essentially, I rate that a 7 out of 10. It's good, you can use it. It's not the one I would recommend, but it's not the end of the world if you go for it. So the last approach, this is the one that I use for pretty much all my modules, is the ALC Loader Approach. It's a bit more complex, more around the boilerplate that's actually required for it. But essentially what you have here is that you have a PSM1 file, so that's different from before, that has some sort of setup code to sort of set up the ALC and get things ready. You have this load context DLL, which is something specific for setting up the ALC and getting things all working. That would be unique to your module, so there's no chance of actually having a conflict. And then from there, your module commandlets and everything is located inside the ALC, and then you can call your dependencies directly from there. So let's have a look at that one there. So if we go to ALC Loader, we can see the PSD1 here is slightly changed. We now call our root module as the PSM1 file. Inside the PSM1, there's going to be a bit more boilerplate, so bear with me as I try and explain this, but if I sort of miss things or go over it too quickly, I'm happy to explain some more after this talk. So essentially what we're doing is that we're going to check, hey, is this assembly been loaded before? Essentially, has someone imported this module in this process before? So it's sort of like a little check that we have on there. If we're running on PowerShell 7, we check, okay, yes, has our load context been loaded before? Once again, has someone loaded this module before? If it hasn't, we then just call add type to call our load context type. From there, we use our load context and this static class called initialize to import our actual module and return that assembly, which is now located inside an ALC, so there's going to be no conflicts. We then use import module to then, with that assembly argument, to import that assembly object that we have on there. PowerShell 5.1 doesn't have that concept of an ALC, so we just do a similar thing where we call import module either on the already imported assembly or on the path of that DLL that we have on there. So there's nothing too tricky happening. Unfortunately, there is a bug in PowerShell. I've opened an issue, but nothing's sort of really happened, gained traction. Need to try and reinvestigate to see what's happening, but we do need to add this sort of extra snippet of code at the bottom here. In case someone calls import module twice on your module, that's just to make sure that your commandlets are actually exported. It's nothing really related to the ALC, it's just a bug inside PowerShell itself. So if we look at the code itself, the first one that we'll look at is our load context, so our ALC loader shared load context. So we go to the shared, we can see we have a single type on here. It inherits our assembly load context, and there's a whole bunch of things that are happening. So in this case here, we have our initialize method at the bottom here. We have some sort of locking and other sort of static checks in here just to sort of help it work if you're running this in parallel. It's not needed, but because this is all boilerplate, it's just easy to have in there. We're saying, okay, have we already loaded this one here before? If so, just return that. We don't have to do any extra actions. Otherwise, we're going to get our binary directory, our bin one, find all the DLLs inside there, find not ALC loader.shared, but ALC loader. So we're sort of essentially stripping the .shared away from that one there, and then create our load context object and return that assembly. The load context objects do similar things where essentially it keeps that directory stored internally, so it knows where to look for DLLs. When it is being requested to load an assembly, okay, does this match? So does this DLL exist in the path? If it does, load it inside the ALC. Otherwise, fall back to the default action, which is either going to be fail or fall back to whatever PowerShell's loading behavior is. So there's a lot of code that's happening here, and I will admit it's a bit hard to sort of wrap your head around. But essentially, the only thing you ever need to do is take a copy of this code, change this name to something that's unique, so your module name, and that's it. So it's all generic, and maybe at some point this might be included in PowerShell itself as sort of a a handy way of getting it sort of available and easy to use for everyone. But for now, you just need to include it in your projects. The actual commandlets themselves, so our ALC Loader assembly, in this case here, this has the dependency directly on our Tomlin library, so 0.19. Our commandlets themselves can access and interact directly with our dependencies without any issues. So you don't need that shared util, which is a bit sort of hard to wrap your head around. Essentially, it just works like normal. You don't have to do anything special. You can talk to things directly. And then we also have a sort of static class here to sort of test out that static method and accessing it in PowerShell. So if we go back to our tests here, we can see where some of the examples sort of get a bit better. So we do the same thing. We load the old Tomlin version, load our ALC Loader module. We can see, I won't run through it again, but PowerShell only sees version 18. The old version cannot use no inline. The ALC Loader Approach, the commandlet that we're exporting there, can actually get that no inline version. The location of this assembly is in our module and is at version 0.19. And then they're all essentially the same. Where the ALC Loader Approaches differs from our Resolver one is that types in our ALC Loader, so the one that contains all our commandlets, are actually accessible directly in PowerShell itself. So even though this assembly here is located inside an ALC, we can use the normal square brackets syntax to access any of those types, whether they're the commandlets or any shared classes or things that we've defined in there in PowerShell itself. So in this case here, we're going to go through ALC Loader to get our commandlet type, extract the assembly, and then we can see that the location's inside ALC Loader, but the load context for that assembly object is going to be ALC Loader. So this is a very handy thing because you're able to define types that are needed inside both your module and also accessible in PowerShell itself to sort of bridge that gap between the dependencies in the ALC and things you need outside of it. The static method that we had on there, so instead of using reflection, we can just access it like normal in PowerShell. So we define the type name inside the brackets, use our double colon to access the static member. In this case here, it's just the method. And we can see that that assembly for that type there, once again, is also in our ALC Loader. I won't go through the complex types. It's probably a bit much and I'm starting to run out of time. But essentially, it's a way that you sort of wrap your objects around in a shared type inside your module, which then encapsulates your other dependencies, so like TOML objects or other things like that. So the ALC Loader Approach, the pros. It fully isolates your modules and dependencies. Commandlets can use those dependencies directly, so it's simpler to write your code and deal with those dependencies. And then a pro, which I'm going through and I only really found out when doing this demo, is that commandlets and the immediate types are actually accessible in PowerShell. So I won't be able to access the Tomlin stuff, but I can access anything in that ALC Loader assembly and deal with that as I normally would in a module. The cons, once again, need to rethink your inputs and outputs because you can't reference your dependencies directly. So it's hard for modules to retrofit that onto existing modules versus sort of a new greenfield implementation. It is harder to understand. I will admit that boilerplate around the load context is a bit to sort of grapple, but it is mostly a copy and paste thing. You just need to change the name on there. So it's not too hard, but it is extra work that I wish wasn't there in the first place. The third one, you do need a PSM1 with some of those sort of extra tricky stuff on there. It is a copy and paste job with two names changed. But once again, yes, it would be nice not to have that. So out of 10, I rate this a 9. So it's not perfect, but it is pretty darn good. And I highly recommend it if you're creating new modules and you're pulling in .NET assemblies. So the key takeaways from this one here, an ALC is really the only way to fully isolate your .NET assemblies from other modules. That sort of is stretching the truth a bit. There are some other tactics out there, like renaming the internal names of that one there using some special tools. I haven't really done that before, but I find that's more of a hack than a proper implementation. But that might be useful if you have an existing module and you can't implement the ALC side. You do need to rethink your approach on how you expose these types, either through parameter types or output objects, mostly because you can't reference the types directly that are located inside the ALC, except for the ones in that ALC Loader Approach. use the ALC Loader Approach. It's what I've used for, I think, maybe 6 or 7 binary modules that I have here, and it hasn't really broken or failed in any case. So it's the one that I highly recommend. The last key takeaway is that I really need to pester the PowerShell team more to add better support for ALC. So removing some of those boilerplates, or even maybe just making a separate module to make it a bit more reusable. But the one thing that I really want to see is this type syntax here, where we can define our ALC name, a comma, and then our normal types on there. So PowerShell can actually go into that ALC and extract that type using the normal syntax that we all know and love. That's essentially it. I know that's a bit of a complex topic, and I went sort of through some of these things a bit fast, but I'm happy to take questions. If there are none, I can show you some of the modules that I've got that uses this approach here. But yeah, so any questions for this one? Sorry, yes.
This still supports multiple versions of the same modules, or what you give up for one version?
Yep. So the question is, does this support multiple versions of the same modules? I'm assuming these are PowerShell modules. Yep. Unfortunately, no, you still have that limitation of a single PowerShell module on there. And because these are binary or mostly binary modules, you can only have that sort of main one loaded. So it still has that limitation. This solves the issue around .NET dependencies. So like the Tomlin, YAML, Newton Soft JSON, all that type of stuff. Yes.
Microsoft fixing the underlying issue there, so is this kind of experimental?
Yep. So do I see Microsoft fixing the underlying issue? Is this around that reflection hack I had, or .NET assemblies and version conflicts? I don't see them ever fixing this. This is a fundamental thing that they actually changed between .NET Framework and .NET Core 5+. They've explicitly said, no, you can only have one version of the same assembly loaded. I think it's because of how much of, I don't want to say the word here, but how much of a pain it is in .NET Framework dealing with multiple different assemblies. It's a whole other issue dealing with that one there. So they decided, no, let's make it simpler, only one version. So it's the ALCs, the assembly load context, is their solution for this particular issue. Yes.
Are you aware of any PowerShell modules produced by Microsoft that is using this technique?
Am I aware of any PowerShell modules that are using this technique? I believe some of the Azure ones have started migrating across to it. There probably is some other ones. I don't know if the Exchange one is yet or not, but do you know any? Yeah. I think Azure is the main one because that's the one that everybody has these issues with. There may be other ones, but I think it's sort of an unknown new thing, so not many people do it. And a lot of the existing modules, you can't really retrofit it, so it's hard to update existing ones without making breaking changes. Yes? PowerShell Editor Services uses it correctly because it's by the wonderful Justin, Patrick and Andy, I believe. Yeah, so they're doing the good stuff. Hopefully some other Microsoft teams and other people can utilize this as well. Yes.
Yeah, so I did the Spectre console thing, and I've realized that it's been clobbering a few situations with people are trying to use Spectre console and saying, like, oh, it doesn't work. If you load a dual mods with M1, so I'm going to have to deal with something like this.
Yep.
But it has a lot of types of exports.
Yeah.
Like a lot.
Yeah.
And I was wondering if there's any shortcuts, or are your DMs open so I can just ask you questions later?
So this is around PowerShell Spectre Console and how it could potentially utilize the ALC. The short answer is you may be able to do it, but you're going to be giving up a lot of work to try and get it working properly. And then things like your parameter validation, so where you have the invoke Spectre live with your context type on there, stuff like that won't work without either putting another type or changing things completely. So there's going to be some shortcomings. It could be possible, but it's going to be hard without redesigning it from the ground up. I'll go for, yeah, what's your second question, sorry?
The second question was, I think, what you've kind of demonstrated in the first part was a little bit like home-rolled like binding redirects in C#, where I'm used to being like, yeah, I kind of don't care what spectre console is.
Yep.
This wide version.
Yeah. So yeah, the first one, the load resolver is essentially like that. So it's basically a way of saying I don't care, and that works for some scenarios. But it gets tricky when you have like dependencies on dependencies, because the way that .NET binds those links together can get very tricky if there's mismatched versions in what it declares. So it can get tricky, but sometimes it could just be fine. So you might get lucky and things work just fine, but you might also get unlucky and things don't work, and you get users saying, why doesn't this work? So it's a nice way of making it better. It just won't make things not perfect, but it won't fix the underlying problem. Yeah. Yes.
Is there any way you can use like source generators or that like for those sort of those halfway pipes that you have to make, like those bridge types?
So the question is there a way of using source generators for that stuff? Probably. I haven't really looked into it too much. So it should be possible, but yeah, no, I'm not too sure. Sorry. Yes.
Yeah, so I made a proof of concept and source generator module for my talk on the same topic, I think 23, which is called isolate with ISO underneath, for generating like this loader module with input of new. But you still have to, as a module author, you have to say I want loader assembly for my module.
Yep. Okay, so the look at isolate, like ISOL8, that might be a source generator one and a nice way of removing a lot of this boilerplate stuff. So that sounds like it could be a good option there as well. And look at the talk in 2023 from Emmanuel, and you'll be able to see that in action. So cool. Well, thank you very much. Once again, if you have any questions around that, or if you wanted to see it in action from some other modules that I have, I'm happy for you to pick my brain or just ask me questions about it. I'm here to the end of the week. So thank you very much for listening.